This is AP Calculus BC, and we're doing the Unit 7 Objective 6, which is polar graphing, and we're doing areas. Now in 7.5, we already learned the basic formula for area using polar, and we are sweeping triangles as you're going along through that region, and they come from the pole and they go out to the curve. Okay. Now, if you have a couple of curves, and so you're not really wanting the area from that starting from the pole, but the area actually between the two curves, excuse me, a curve shorter from R to the big R, and this should look kind of familiar to you guys because it kind of reminds me of washer method with volume. Of course, this is just area, but if we look at the formula, very similar to the washer method equation. And so now it's still the 1/2 and the function squared, but because we want the area between, so it's the big R squared minus the little r squared. Now, this only works if the alpha and beta are actually matching up to each other for the two equations. Occasionally, you'll run into, you're trying to get an area of something like this, and yet the angles aren't matching up, and so you might have to do them completely separate and do the 1/2 r squared and then minus, and do a different integral with different angles. And subtract out the 1/2 little r squared. Okay, but let's go ahead and take a look here at a couple problems. And now that we have a couple different situations, you know, it's like we need to assess the situation and see what's going on. So problem number 1: find the area inside both the circle. So remember, one petal roses are circles, so r equals 3 sine theta, and the cardioid r equals 1 plus sine theta. Now, it's really important to get a pretty good sketch on this one, and so I went ahead and used Desmos to get us a very good sketch. It's a graph, it's not just a sketch. So we've got the one petal rose, which is the circle, diameter of 3. And then our cardioid. Okay. Now, since we're wanting the area inside both, we're looking for the overlap of the area, and so I think we all can see what that area is. So essentially, you know, we're talking about this situation right here. Okay, but let me clean that up just a little bit right now and make sure that we understand. Now, when we are sweeping things out, you don't sweep out doing a curve. You're sweeping it out almost basically with a straight line. I mean, it's a triangle, but it's a triangle with delta theta thickness, and taking the limit as delta theta goes to 0. And so as we're starting to sweep it out, you have this sort of thing going on. And until we get to that point of intersection between the two curves, we can see that out of these two situations, we're really just doing this this first one right here on the left. And the curve that we're going to is the circle. Okay, now that point of intersection is really important, so we do need to get that point of intersection. So let's go ahead and get that right now. So we have 1 plus sine theta equals 3 sine theta. So 1 equals 2 sine theta, so sine theta equals 1/2. So sine's positive in quadrants 1 and 2. So theta equals pi over 6 and 5 pi over 6. Okay. Now I know that's not an ordered pair, but the angle measures are what we need as we're doing the area. Now I think it seems pretty reasonable looking at this, that this one over here is the pi over 6 and this one over here is the 5 pi over 6, and that all seems to make sense. So our area and so we've got 1/2, and now it starts from angle of 0 and it goes to pi over 6. Okay, and my r is the circle, which is 3 sine theta, squared d theta. Okay, now that's just that one over here. Now the same thing's happening over here, and so you're sweeping out this part right in here very similarly. And so what we can do is we can simply double that, and we'll get those two bits right there. Okay, now that's obviously not the entire area that we're trying to get. We're also trying to get the bigger area, which picks up right where we left off and starts sweeping through all this. Okay, now this, the limits of integration for that, pi over 6 to 5 pi over 6. And we're going to the curve that's the cardioid, so the cardioid is 1 plus sine theta quantity squared d theta. Okay, so cleaning up that setup that we just did, the first integral, the 2 times 1/2, that cleans up, and we're left with the integral from 0 to pi over 6 of 9 sine squared theta d theta. And we're taking advantage of the limits of integration going from pi over 6 to pi over 2, and we're going to double it. And then multiplying it out, we got 1 plus 2 sine theta plus sine squared theta. The sine squareds, we need to use half angle formula substitution if we're not using any technology here, so here we go. So substituting, and I can bring the 1/2 out and the 9 out as well. So 9/2, 0 to pi over 6, and we would have 1 minus cosine of 2 theta d theta. And okay, so over here we have pi over 6 to pi over 2, and we have 1 plus 2 sine theta. Okay, the sine squared right here, half angle formula substitution, and so I do have plus 1/2 minus 1/2 cosine 2 theta d theta. Okay, so we have 9/2 times, we have theta, and let's see, negative cosine 2 theta would be the derivative of negative 1/2 sine of 2 theta, evaluated from 0 to pi over 6, plus, okay, now the 1/2 here, excuse me, the 1 and the 1/2, they can combine, that's 3/2. And so we have 3/2 theta, and the plus 2 sine theta, that is the derivative of negative 2 cosine theta, and then the negative 1/2 cosine 2 theta, that would be the derivative of negative 1/4 sine of 2 theta. Okay, so evaluating all that, we get, let's see, we have 9/2, and I would have pi over 6 Okay, twice pi over 6 is pi over 3. Sine of that is root 3 over 2. So and plugging in zeros, we get zeros for both parts. Okay, and moving along, I've got 3 halves times pi over 2. That would be 3 pi over 4. Cosine of pi over 2 is 0. 2 times pi over 2 is pi. Sine of pi is 0. Okay, 3 over 2 times pi over 6, that's 3 pi over 12, otherwise known as pi over 4. And cosine pi over 6, that's root 3 over 2 times 2, so negative root 3. 2 times pi over 6, so that's pi over 3. Sine pi over 3 is root 3 over 2. Okay, so we have, let's see, 9 pi over 12, 3 pi over 4. Minus 9 root 3 over 8. I've got plus 3 pi over 4. I've got minus pi over 4. I've got plus root 3. And I've got plus root 3 over 8. Okay, so 3 pi over 4, 3 pi over 4, that's 6 pi over 4 minus pi over 4, 5 pi over 4. And I've got negative 9 root 3 over 8. We want a common denominator here. So let's see, 8 over 8. So it looks to me like the negative 9 root 3 over 8 and the 8 root 3 over 8 plus the 1 root 3 over 8, those eliminate each other. And so our final answer here, the area is 5 pi over 4. Okay, we're going to try one more, then we'll be done with the notes. Using the same two equations, r equals 3 sine theta and r equals 1 plus sine theta, find the area outside the cardioid but inside the circle. So outside the cardioid, let me erase that part first. Outside the cardioid, so not any of the shade that we just did, but inside the circle. So it looks to me like, actually I'm going to erase the other part we just did. Looks to me like we are doing this, which that appears to be the second formula that I gave you guys today. And we can go from pi over 6 to 5 pi over 6, or we can take advantage of the symmetry and go pi over 6 to pi over 2 and double it. And it works either way there. Okay, so the area, 1/2. I'm going to go ahead and double it. So 0, sorry, not 0. Pi over 6 to pi over 2, and I'm going to double it. And my big R is the circle, because it's the one further out. So the circle, 3 sine theta squared minus, and my little r is the cardioid, so the 1 plus sine theta. Squared Okay, so obviously the 2 times 1/2 cleans up. Pi over 6 to pi over 2. And we have 9 sine squared theta. And we just recently multiplied stuff out like this, so we know it's going to be -1 minus 2 sine theta minus sine squared theta d theta. So we have pi over 6 to pi over 2. We have 8 sine squared theta minus 2 sine theta minus 1. And okay, so the sine squared, we need to do our substitution. And so we're going to have 8 times 1/2, so it's going to end up being 4. Okay, so we've got 4 minus 4 cosine 2 theta and minus 2 sine theta minus 1 with respect to theta. Okay, so I do have 4 minus 1, which is 3. We can go ahead and take care of that. So we have 3 theta. The minus 4 cosine 2 theta. Okay, so the cosine 2 theta, that's the derivative of sine 2 theta with adjustments. So this would be minus 2 sine 2 theta and minus 2 sine theta. So that's the derivative of plus 2 cosine theta from pi over 6 to pi over 2. Which, okay, so I get 3 pi over 2. 2 times pi over 2 is pi. Sine of pi is 0. Cosine pi over 2 is 0. 3 times pi over 6 is pi over 2. 2 times pi over 6 is root 3 over 2 times that 2 is minus root 3. And cosine pi over 6 is root 3 over 2 times 2 is plus root 3. So we have 3 pi over 2 minus pi over 2. And these two things eliminate each other. And so we're left with